So in this lesson now, we are getting into our similarity postulates or similarity theorems. So there are the three that we are now going to start bringing into our similarity problems. So here now you have the angles. So if you have two angles that are congruent, now keep in mind, right, they're corresponding, then you have two figures that are similar to each other. So like here, for example, yes, this says 43, but if you think about it, right, these angles have to add up to 180. So this angle here is 47 degrees, which if this is rotated 90 degrees, then now you've got C and F corresponding to each other with your right angle here. So these two figures are similar due to AA. Now, we've been talking about already the three sides. But if all three sides are proportional, right? If you have the same scale factor that's being used here, then you have SSS. All three sides are proportional. Then if you have two sides that are proportional with the including angle congruent corresponding, then you can also have SAS. So you have similar figures. So again, right, like notice 5 times 2 is 10, 7 times 2 is 14, and you have the including angle between them. So due to the two proportional sides here with that same factor, including angle, you have SAS. So now these are the three now we're going to be adding to our discussion on similar figures. So like here, for example, here in example 1, we're just identifying if we have the similar figures, and then we're going to write the similarity statement if so. Now notice this has been rotated, so CD is corresponding to CA. So we are going from 2 to 4. So notice 2 to 4, so 2 times 2 is 4, and then 6 is corresponding to 12. So do we have proportional sides? Yes, we have proportional sides. And if you also check, if you cross multiply, you get 24 is equal to 24. So we have proportional sides. Now, that's only two of them though. We don't have the third, so we can't say SSS. However, do we have an including angle? Yes, because we have vertical angles, and vertical angles are always congruent. So we have two proportional sides with the angle between. So yes, we have SAS, which means that triangle CDE is similar to triangle CAB. So then example 2. Now notice we have no side lengths, but let's see if we have enough information. We have two right angles, and right angles are always congruent to each other, and we also have vertical angles. So do we have enough information to state that these two triangles are similar? Yes, because of the AA similarity theorem, which means triangle CAB is similar to triangle CDE. So go ahead and pause the video now and do these two U-tries on your own. So here in the first U-try, you should have noticed that this was a no. They are not similar. Yes, we have our two sides here and we have our vertical angles, but are the two sides proportional? No, because if you notice, if this was 16 and 16, now let's say I match up and go from 16 to 40. That is a scale factor of 2.5. That means if I have 16 here, then I should have had what? 40, because I'm using the same scale factor. So due to that, these two triangles are not similar. However, in the second U-try, these two triangles are similar to each other due to side, side, side. Because if you were to go from, let's say, the smaller to the larger, let's say we're doing an enlargement, you have a scale factor because 3 is corresponding to the 4.5, and the 2 is corresponding to 3. Same thing here, because you had two isosceles triangles. You have a scale factor of 1.5 if you're showing an enlargement. So that means here, triangle PQR is similar to, triangle UTX. So now applying and solving for variables here, like for example, we have two similar triangles due to, and sorry, I forgot to show you guys that these are going to be similar. Actually, I think you could already see, because if I've got 40 and 80, then that means here the missing angle is 60 degrees. So now notice the corresponding angles are all congruent to each other. So why are these two triangles similar to each other? Because of the AA theorem. So we can state, therefore, that the corresponding sides are similar, or they're proportional to each other. So let's say I wanted to solve for x here. So x is corresponding to 8. So I've got x is corresponding to 8. Now you could have x to 8 here, or you could have x to 8 here. So I'll do it the other way because we've kind of focused on the other direction. Is equal to, so let's say here now, would it make sense to use 6? Well, no, because 6 right now is corresponding to y. So we're going to hold off on that because we don't want two different variables, right? But 3 is corresponding to 5. So now here, this is just a good old cross multiply, right? So now here you've got 5 times x, 5x is equal to 8 times 3, which is 24. So then when you divide, you get x is equal to 4.8. So then same thing here now to solving for y. Now you could still use the 3 to 5, right? So 3 to 5 is equal to, that means now here, now I can use 6 to y. So 6 to y. So same thing here, cross multiply, right? 3 times y, 3y is equal to 6 times 5, which is 30, and y is equal to 10. So due to the AA theorem, we can state that the sides, corresponding sides, are proportional in order to solve for x and y. So now here we're given that BE is parallel to CD. So technically here, we could also use AA theorem, right? Because if these two sides are parallel, then what is the relationship to show that E is congruent to D? They're corresponding. They're in the same spot, same position. So this is another AA theorem. Also, if you recall, if these two sides here are parallel, we also have the triangle proportionality theorem, which states that we are creating two similar figures. However, we don't have the two sides here, so we can't really use triangle proportionality theorem. But here we can state that these two sides, or these two triangles, are still similar because of the AA theorem. Now keep in mind though, 5 to x is not a ratio because these sides are not a ratio here. Keep in mind, we're going to be focusing on our two right triangles, right? We've got ABE and ACD. So here we've got 9 to 5, so 9 to 5. But keep in mind, this is equal to our large triangle, which is 12 to x. So again, here, notice how AC is 9 plus 3, which is 12. So that's how we need to set up and solve our proportion here. Now we can go through and cross multiply. So now I've got 9 times x, which is 9x, which is equal to 12 times 5 here, which is 60. So now here, when you divide 60 by 9, you get x is approximately 6.6 repeating, so we can round that to 6.7. So go ahead and pause the video now and try the U-try on your own. And here we go. So now with this U-try, these two triangles, if you were to test this, are similar by SAS because the included angle 60 and then the two sides here are actually proportional. So you also had to make sure to identify where that corresponding angle is, because here you should have then noticed that 12.7 is actually corresponding to 25.4, and 7.5 BA or AB is corresponding to 15. So here, because of those two sides, that create that 60-degree angle. So you had to identify where that corresponding angle was located, which means here, that's how you can, and I'll start off with the angle measures. So notice how this got rotated and reflected to create this image here. So angle F, that means if you were to notice here, that if A and D are corresponding, then that means F was corresponding to B. So that's why angle F is 84 degrees. That means that angle E is 36 degrees because it's corresponding to angle C. So then the last part here now is to solve for EF. Now, there's different ways you could go about this. You could do the proportion, right, where then you cross multiply and solving for our X here. In some cases, people could see, well, I know if I'm enlarging, my scale factor is 2, because 7.5 times 2 gives me my corresponding side of 15. 12.7 times 2 gets me my corresponding side of 25.4, which means 11.2 gives me my corresponding side of 22.2. Now, for those of you set it up, then let's say here I've got 7.5, right, corresponding to 15 is equal to, so here we've got 11.1 is corresponding to X here. Now, again, you could have used the 12.7 and 25.4, right? There's so many different ways that you could set up and solve this problem. So here I've got 7.5, right, times X here. So now here you end up with 7.5X is equal to 15 times 11.1, which will get you 166.5. Then now notice, right, we're solving for X, so now what do we need to do? Divide, right, by that 7.5. And when you divide, notice how you should have also gotten 22.2, which is the same we got here, showing that same scale factor. So now just getting into our proof, right? We always start with our given information. So what is given to us? That we have two parallel sides, right? PQ is parallel to ST. Now we are proving that the two triangles shown here are similar to each other. So that is our last statement. PRQ is similar to triangle SRT. Now, PQ is parallel to ST. And notice how the statement here is how RPQ is congruent to RST. Now, notice this has been here. Oh, sorry, that's a typo. I just realized. I'm sorry about that. That was supposed to say RTS, right? Sorry about that. So RTS. So here, you've got these two angles congruent to each other. Well, why are they congruent to each other? Because they're inside the parallel lines on opposite sides of our transversal. So we have alternate interior angles. Now, what else do we have? Well, I also noticed, now you could go two different ways, really, if you think about it, right? We could also state that RQP is congruent to RST. Why? Because of alternate interior. You could also state that PRQ is congruent to angle TRS. Why? Because of vertical angles. So you could go different routes with this. However, do we have enough information to state that these two triangles are similar? Yes, because of the AA theorem. So now here, going to our application piece, we are solving for BA. So notice BA is the entire side here. So we are solving for BA. That is our X, that is our unknown. Now notice here, we do have parallel sides, which means that we've got base angles that are congruent to each other because of their corresponding, right? F is corresponding to A, G is corresponding to C, making them congruent. So because of AA, we can state that these two triangles, BFG, is similar to BAC, which means here that I've got the corresponding. Now, do we know what BF is? No. So here, what I'll do is, since that's what we're looking for, I'll label BF as my X to solve this problem. So we've got X and 6.5 for our side lengths here. So X to 6.5, or you could put X to 6.5, right? It doesn't matter. You could set this up different ways. That means here, we put 17? No, because we need the whole side here, BA, because that's what's corresponding to BF. So we can't just put 17, we can't just put X, but the two added together make BA. So this is X plus 17. So X plus 17 is corresponding now to, and then to the ratio of 24. Notice now how we have those corresponding sides equal to each other. Now we can go through and start solving for X here. So now with cross multiplying, you've got 24 times X, which is 24X, which is equal to, now notice, right, this is our expression, so 6.5 times the whole X plus 17, right? Now we need to distribute. 24X is equal to 6.5X, but now plus 110.5. So now we can go through and gather our variables, right? So subtracting here 6.5x from both sides. Now we've got 17.5x is equal to 110.5. So now we can just go through and solve for x, right, by dividing by 17.5, and you end up with x is approximately 6.3. Now, x is 6.3. So is that our answer? Is that what BA is? No, because keep in mind, that is technically just what BF is. BF is 6.3. So if we want to know what BA is, make sure now to add 17, right? We need 6.3 plus the 17. So that's why BA is approximately 23.35.